Okay, good morning everybody, and also good morning everybody there online. First of all, I would like to thank the organizers for making this great conference, putting together. It's very good. And also very thank you to Andrew for this fantastic talk. And I want to talk about writing the mark. And first of all, I would like to just give a little bit of context. First of all, I would like to say a few words about West Den Haag. It's a contemporary art space, and we are located in the former embassy, which is in the city center of The Hague. It's a building by Marcel Breuer. And we have a team of 15 people, and two of them are here now helping us with the filming. That's Thijs and Yael. Yael is a writer and a philosopher, and Thijs is an artist. And at West Den Haag we have exhibitions. Currently we have an exhibition with Pierre Bismuth, a French artist. And Pierre Bismuth is also the screenwriter, or one of the scriptwriters of Eternal Sunshine and Spotless Mind. And there will be a talk about that later today, I think, even or tomorrow. Today. And so he won the Oscar for writing the script for the film 2004. And so with this Oscar, he could also make his own Hollywood film, which he did in 2016. It's called The Where's Rocky 2, and it's a film with a real artist, a real LA detective, real Hollywood screenwriters, and a very fake rock. I can only recommend to watch the film. We always have like 4 to 5 projects running parallel. Another exhibition we have currently is called Paul Robson. That's a one-year presentation. There's also a reading group currently about Donna Haraway. We have guided tours, events, and debates and symposia. And there's also one space at the West Den Haag which is called Alphabetum, and that's dedicated to the letter. A few words on Underware. We are a type foundry. Here you can see Sami and Bas and myself. And we design the typefaces, digital typefaces, so people can use them. And the interesting thing when you design typefaces is that you design a typeface and at a certain moment it's published and you never know what people will use it for. So for example with this one, Bello, it was used for example for the French election back then with Hollande. Or, like it's used by artists. Or it's used sometimes in the football stadium, really big. But perhaps the most interesting thing is it's also used in the Donald Duck in the virtual world. So you see that guy who draws the script uses the typeface to make the shop lettering here. And we are always interested also to play around with letters. And if you look carefully, you can read here Underware. It's a bit more calligraphic. And so here I help you, UMPER, and so on. But it's designed in such a way that you can just rotate the whole thing and it still says Underware. So all the letters have 2 functions. And yeah, you can just rotate it as long as you want. Okay. Another way you can work with letters, let's say typographically, is that you can argue do we really need those 26 letters? They can do it in literature to write literature without certain letters, which is called lipogrammatic. So we said okay, when we have 26 letters, perhaps we can do with less. And yes, you can just use 3 shapes, and you can still read the whole thing. But what's interesting is that even with one form, you can read the whole thing. One very big development, what I quickly want to talk about, is variable fonts. And this happened in 2016. It was developed by Adobe, Apple, Google, and Microsoft, and together they developed a new standard for digital fonts. And this is called variable fonts, or more technically, it's called OpenType 1.8. And it was released in 2016, and probably nobody heard about that, hopefully, here in this space. Did anybody hear about variable fonts before? Okay, very good. The interesting thing is that it was released in 2016, And still today, hardly anybody knows about that, but in practice there's a 100%, nearly 100% support of that. So I believe everybody's smartphone here in this space will support wearable phones. Or also all the computers from the people who follow online, they support wearable phones. And what wearable phones are about is that you can have one font file, and this font file can interpolate directly different weights. As you can see here, like all the different weights, what you see of this one typeface, here's title, that's one wearable font which is interpolating directly on the user's computer. And the reason why the big companies wanted to have the wearable fonts is if you have such a website, for example, before 2016 you had to send lots of different font styles. And now you can only send one font file, which is like only one HTTP request, and this will interpolate all the fonts which are required. So the reason why they did is they just wanted to make the internet faster. That's a very important thing for the internet. What I find interesting is if you look at text and letters, characters, then we all know about the big transition in text from static to dynamic through hypertext and the internet. And it started somewhere in the 1970s, and meanwhile we learned or we saw that it created new kind of media, for example social media. And this took a while. Social media would have been also possible in the 80s or the 90s. The technology was all there, but we didn't understand what dynamic text was really about. And the same perhaps could be with the letter, with the characters. You know, like verbal fonts were just introduced, but they are now supported. And on the long run, the dynamic letters could have an equal big impact on society as the dynamic text perhaps, and perhaps could bring us to a new kind of writing. But yeah, of course, we don't know. It's like all speculative, but what we do know is that something's happening already now. And so, until shortly, there was basically two kinds of writings. One was like writing by hand, the chirography, and the other one was writing with prefabricated letters, which is the typography. But now that we have the dynamic letters, I believe we also need a new term for that, and that is called grammatography, and that's the writing with dynamic letters. Rocks and boxes. If you look at traditional letters, static letters like A, B, C, like the alphabets, and the mark of distinction, there's a big difference between those two. The one comes out of the typographic world, and the other one, I believe, is opening a new world, namely the grammatographic world. And I think one can be perhaps more understood as a rock, and the other as a box. And again, it's difficult to predict what will happen in the future, but we can look at the past, what happened there. And as I just explained, the internet, initially it was not made for social media, it was made for sharing computing power. But meanwhile, we know that other aspects are have much more impact on our society. And the same perhaps could happen with the wearable fonts. Like initially they were made just to interpolate different weights and to make the traditional web be the same but just faster. But at the same time, we can have a totally different situation, namely if a thin A can be interpolated in the thick A, yeah, the A can also be interpolated into a B. And that's something totally different than our idea on the typography and static letters. So at Underware we looked like, yeah, is it possible, how can we do that? And here's one example, a very simple example of such a variable font. So what you see here is not animation, but it's a typeface, but the typeface has 26 dimensions, and through those 26 dimensions we can just interpolate every character in any other character. So there's basically only one character, which is a kind of causal character, namely it is what you make out of it. And once you have that, you can just interpolate also whole words into other words. But again, that's not an animation, that's a text, just the same text as you have in your Word program. And once we did that, we were curious, like, can we also do it more calligraphic, more in a writing way? So we made another font which consists just out of a single infinity stroke. And we designed it in such a way that we said, like, yeah, with this one infinity stroke we can create or write everything. And we created a tool, we call it Penstrument, and the Penstrument is controlled by a keyboard, but it has like multi-dimensions. It also recognizes like the pressure and the ratio of your connection and also your movement. And with this we can control this infinity stroke, and we can create the letter. So what you see now is a short movie, and what you hear, the music is just like using the same information, but it's a synthesizer, and the other is a letter synthesizer, and they are just synced because they are controlled by the same input. So again, what you see here is a typeface, and that's controlled by this keyboard. Do the people at home, do they hear sound? Okay, no, anyway. So what you design here is not the form of the letter, but you design how the single stroke has to be controlled to form the letters. And because it's just a single stroke, you can interpolate anything into anything else. And here another example. And everything is controlled by this one infinity stroke. So while working on that, we said, like, okay, that example what I just showed perhaps is more an aesthetical perspective on dynamic fonts, but perhaps you can also focus on different aspects like instructional and logical. So here's another example. That's the Bello typeface, what I showed before, but we made a dynamic version which is written, and the benefit you have once the letter is written, if you have, for example, Chinese, does somebody speak Chinese here? It's important to know the stroke order and also the stroke direction to understand the word. So that way you can imagine that the bellow is just included in the system, and then you select the text. When you learn the Chinese, you don't understand the character, so you select it, it's like, okay, please write it for me. And then the typeface has included the writing instructions, so it knows exactly which stroke is written when, in which direction, and so that's very simple for people to understand and to learn the Chinese language. That's a saying in Chinese for people who learn Chinese, like wrong, strong order. And probably now you also understand, when I saw that, I saw immediately this challenge, like, yeah, what's happening here? Yeah. I looked at it as a character, not as a drawing. And after the last conference, we made a little exhibition, and for the exhibition we made a little website called Writing the Mark, and there we applied the variable font technology on the mark of distinction. So here again, that's a typeface, and the typeface has 4 axes or 4 dimensions, you could say, and by controlling those 4 dimensions, you can modify the character. And now you can imagine, once you do that in a correct way, you can construct all the expressions. So that's just like a browser for the typeface. And then I made a little demo where it's just like generating like randomly expressions, but this is just like text. So you could select it and modify it. And there was also a little parser where you had the parenthesis notation, and it would then be translated in real time to the verbal font. Yeah, Luke Hauptmann talked about this yesterday. It's the first character of the poem which is introducing laws of form, and I'm always intrigued by this sign or by this character. And yeah, everybody I think has a different way to understand it. My way is I see it as a sign for this which cannot be expressed by a sign. But then perhaps it's like a signifier without anything signified, or yeah, at least at the end perhaps it's a sign which is not a sign. And I find it especially interesting that George Spencer Brown started with this. Basically it's the first character after the introduction, because once you look at the mark of distinction you can also wonder, like, ask yourself, what is it? And yeah, somewhere it says like, it's marked with a mark. And when I look at it as a type designer, I also see a shape. And the shape only exists because it has a contour, and the contour separates the inside from the outside. And that's basically what type design is doing. The only thing we are doing is creating like insides and outsides, and with this we can create shapes. And so that's how you can explain type design, what it is about. So in that way, I believe, or for me, it's the character. Okay, yeah. Balanced characters. At a certain moment, George Spencer Brown said that the mark of distinction replaces two characters. It's basically just replacing two characters with one character. And if you look at this problem, like, that's really hard for us to understand those balanced characters. And in that way, Lisp always got criticized by not being easy to understand, but I think it's not the problem of Lisp, but it's the problem of the typographic system. So we should blame Johannes Gutenberg that the system is not good. So in that way, balanced characters, they pretend to be boxes, but in fact they are just rocks. And this makes it so difficult. Like, for example, if you write with the hand, it's so easy. If you have the square root, you just make the square root as long as you want, and you put the stuff inside the square root, which is very easy and very simple, and we understand it. But once you do this in a typographic system, these things can happen, and then they say, like, that's an error, but it's not our error. I think it's the error of the system. So in that way, shaping distinctions can create a change there. First of all, we have to look at the writing directions. Like, there's a lot of different writing directions, but the most common are left to right and right to left. And if you look then at the mark of distinction, Graham once told me that he believes that, or that's the official story, that the shape is formed by our Western writing direction from left to right and bottom down. And so there we have the mark of distinction. And when you typeset it, the writing directions goes from left to right, but the alignment direction goes the other way around. So far everything is simple, but once you put something in the mark of distinction, I think there's a different alignment, because in my idea it should be aligned to the left, because then it cannot fall out. So there's two alignments going inside each other, left and right. And this makes it difficult to typeset and also to rasterize expressions. But then if you consider how do you write these expressions, it gets, at least to me, even more confusing. Because I always wonder, what do you actually write when you write the mark of distinction? When you compare that with a classical keyboard as we use it, you could say, we only need one letter, one character, that's the mark of distinction. And yeah, that's it. And then we can just get rid of all the keyboard and do this. And perhaps there's also no caps lock. It's just this simple keyboard. But then you look at those two possibilities and the problems or the questions arise. Writing such a sign, character, letter, typographically, we would always expect that we write it and we end up after the sign. And so because of that, we always believe that those expressions should be written like from left to right, so we have like 1, 2, 3. Once you try to apply that to a typesetting system, the problem arises with the third sign, because here there's already 3 possibilities. This could happen, or this could happen. And this makes it very complex, because then we would have like, we would need to have 3 other keys for those 3 situations. So perhaps there's something wrong in the way we think about that. Perhaps it has to do with our idea about writing with rocks, about typography, namely the typographic position. I believe once you write with boxes, there's 2 possible positions. And William Bricken, I think, explained that very nicely, very clearly, that once the first mark of distinction is written, the second one can be either written outside or inside the first distinction. And I think this is how we should approach it. So in that way, what I write is not the mark of distinction, but it's the position I end up. So basically, when you write the first, you write already the second one, and that has a total different consequences than in typography. So basically, you write inside and outside. And so you write into the future, which is somehow also what a program is doing. Program, it's the future what we are writing, not the past. So in that way, this keyboard doesn't make any sense. What we need is such a keyboard, namely a keyboard where the cursor either ends outside or inside. And once I have this keyboard, this expression gets written in a way that I have the right key. So I write the sign and my cursor stays inside. I write the second one and the cursor stays outside the second one and the third one. So that's, I think, the writing order of such an expression. And the same, like if you want to have a different expression, the writing order would be like this: 1, 2, 3. And yeah, what about the rocks? This can be combined with a classical typographic keyboard. And so you would start with writing the mark of distinction, cursor stays inside, I write the A. I have one more key, that's the exit key. With this I just exit the whole expression and then I go to the B. Where it becomes a little bit more complex is once you want to edit this whole thing. Once you edit it, you can argue like, what do you, for example, delete with a backspace key in such a situation? Do you delete like just the mark and then you get this? Or do you delete everything what is inside the mark and you get this? Or do you have even like a more strange ideas like, yeah, those things should be combined because they have the same level of nesting and you get this? I think at the end, we have to talk about that. One thing about the talk of Graham yesterday, very nice talk, very nice presentation. And perhaps you saw that there were also like renderings, expressions. And that was actually the first official application of a new program, what I present now. And so for today, I have put together a little program where you can just type your expressions on the website and it will like directly be converted into a picture. And then hopefully this will help also people to write papers about the mark of distinction about George Spencer Brown more easily, because how Graham already told yesterday, it's a big limitation at the moment that we cannot really use the notation system of George Spencer Brown. So hopefully this helps. Yeah, and it's like just writing the mark.org and then render, and then you can just query the whole thing with your whatever you want. So for example, this would be A implies B. And because it's all used like based on the typographic system, you can also use emojis. And then you would say, yeah, why would I need emojis? Like in the little booklet what we published at West, Dirk Becker wrote a piece and then he uses the illustrations And also this formula can be easily just made with this online tool. And it also works for complex things. You know, that's just the way, and you can query the whole thing with the notation, and then if you add at the end A equal D, it will directly download it. So you can process like thousands of formula in with one little script. And yeah, so that if you look on the website, Writing the Mark, there's a link here. Okay. My final point. I believe that in the next few years we could see a new kind of writing appearing, because after like letters were developed by handwriting, like hieroglyphy, and then the encoding happened through typography, which created the knowledge society as we know it. I believe that a new kind of writing can appear, namely that of grammatography. And at the same time, I believe it can also have an impact for the history of programming, which is, I think, also the writing aspect is very important in programming. And I see that, you know, the first fundamental idea was applying object-oriented programming. And then in the last years, people say, like, yeah, no, it's not about the objects. It's about that we have to have language-oriented programming, namely a programming language which allows us to make new little languages for each little problem. And then perhaps the future could be annotation-oriented programming, where we create grammatographic notation systems, allowing a totally different kind of programming. Thank you.
Absolutely amazing. Absolutely amazing. You've shown just what the future. Oh, sorry. Absolutely amazing. You've shown what the future may hold. I think that's absolutely fantastic. On a personal note, this is going to set me free, because the problems that I've had drawing up these very long expressions, much longer than those in the laws of form itself, has been a bit of a nightmare. And the fact that I can just put it into my computer and get out these really precise, accurate expressions, for me, it's an absolute joy. It's an absolute joy. So that's not a question, that's simply a comment. But my question is the infinity stroke. Can we have another look at that? Does it have to be in that form? Why does it take that particular form?
Because we spent, as natural as it looks like, as specifically it is designed. The infinity stroke has to be defined in a very specific way, so that it allows us to create all the letters how we know them currently. You know, the starting point is we have a typesetting system. We have a kind of perception of how letters look like, and the complex thing is, it's not about the uppercase. The lowercase is very difficult to put together. So before this infinity stroke, that was B, we had another one called Y, and that could only make uppercase. And then with the B, this infinity stroke was designed in such a specific way that we could have within this in this infinity stroke all necessary parts to required parts to make a lowercase and uppercase and figures and whatever. You can also, and once you do that, it's interesting because the complexity of form in lowercase is much higher than in uppercase. But once you can make like a Latin uppercase, lowercase, and figures, you can also do a kanji, for example, because basically it already has enough possibilities.
Thank you.
Other questions online?
There's one in the back.
Thank you very much. That's very fantastic talk. So I'm looking forward to see how it goes. I want to come to the rescue of Gutenberg in a way, because I feel that the system Gutenberg set up in the way how the metal type allows for a spatial layout in all directions, and the construction of the metal or wood elements back in the days, that this really allows for writing in all directions and yeah, if you would do the work of typesetting in the old-fashioned way, that would be allowed. I think the problem starts with the digitization of typography and the processes of programming them and how to because then you have a programming language and problems arising there, coming from a different system. That's what my feeling is.
Yeah, I totally agree. I totally agree. You know, like that's, I think, communicating to a computer is different than communicating through people. And the system we have, the notation system we have, was made for communication between people, but not for communication with machines. And therefore, I'm always surprised that we still have this old-fashioned notation system, namely that of Gutenberg. You know, like Gutenberg did not consider to make the best notation system to communicate with a computer. But once you think like what a computer is doing is like the computer one of the most important thing I believe a computer is doing is putting something into something else, and therefore we should have those characters where you can put something inside another character, but that's just a total different idea than what Gutenberg created. But of course, like it's not that one is better than the other, it's just at the end, you know, it's adding new possibilities. And therefore I made also the comparison, for example, with social media. You know, social media is not replacing the old media, it's just giving more possibilities.
Thank you very much. Absolutely wonderful project.
Yeah, incredible.
Two things come to mind which are interlinked. One, at the onset of printing or movable type, there was actually a very brief period in which the, as it were, aesthetic goals changed from being something that was tied to a manuscript page to something that acquired a whole new free-floating form. And it was a relatively brief period in which this happened. We often think of the introduction of printing as being almost like a punctate event, but it came along with a change in the goals of the typesetter and it freed itself from the archive of manuscripts. Now, given the last two talks, given Andrew's talk and your talk, I wonder, and the amount of effort that went into designing that infinity stroke, I wonder if there's not a well-defined task. I never thought I'd say myself saying something like this. A well-defined task for machine learning. Drawing on randomness and using, well, something like desirability. I won't say intelligibility, but allow the aesthetic goal itself to transition, much as it did at the start of printing. It seems like one could combine Andrew's idea with your design goals and come up with a well-formed machine learning task.
Yeah, I think Hofstadter did prove very well that one of the biggest problems we still face is if you have, for example, if you design a typeface, and I design A, B, C, D, and then I ask the computer to design the next letter for it. It's a very difficult program nobody can yet today write. You know, it's the same with the capture. You know, like once letters are like stretched and twirled and so on, we can still recognize it, but the computer has a hard time. And I think that's something we did not yet accomplish, namely to explain to the computer what a letter is.
That's true. But Hofstadter was still working with letters. His Gary McGraw's PhD project with Hofstadter still was constrained. He wanted 26 distinct shapes. Mm-hmm. The infinity mark changes that goal.
Yeah, what we actually, I have to admit, like what we did once is we had the infinity stroke and we had defined like the location for the letters, but then we also made a little program to just let the infinity stroke find their own locations and then feed this into a text recognition program and see like what characters the text recognition would discover. And so we had indeed, you know, that's interesting to see, but they were never, it was interesting but not convincing.
We can handle another.
Yeah. This is just off the top of my head. I wondered if you looked into the idea of encoding song, because at the moment, if you've got a song and you want to write it, you've got to write the words, then you've got to write the notes above. Whereas you could actually encode, put the pitches into the font
So you only need 7 different distinguishing things in the font, and you can actually encode the music as well to a degree.
Yeah, I think what's interesting in that perspective is that there are important changes happening at the moment. Like, for example, with emojis, you know, like we have the handshake emoji, which has 1 Unicode. But then they said, like, no, we need the handshake emoji to have like 1 skin color on the left and 1 skin color on the right. And once you have that, you would have like I think 64 handshakes. So what they said, like, we don't want to add 64 Unicode code points. So what we now have in Unicode is a sequence. It's a sequence of like 3 code points, but which are represented as 1 code point. So those sequences, I think that's what we can use for the music notation, but that's what we can also use, for example, for encoding the expressions, because encoding an expression, we would require more than one dimension, I believe. At least this is how I see it. You cannot, because once you have, you cannot connect every possible appearance of the Markov's distinction to a unique code point. You need a different setup. It has just, what I try to show with this axis is it has a certain space, a position in a more dimensional space. So I think this with the sequences, I don't know how it will look like, but I think that's something to discover in the.
All right, that's probably good. So let's thank Akiem.
Yeah.